At this point, we understand the mechanism that is driving climate change and its association with human activity, namely the burning of fossil fuels. In this final section, we will be looking at the phenomena that are already occurring due to the higher average global temperatures that the Earth is experiencing. And this is not a complete list of the observable effects of climate change, but it includes some of the major ones, and it includes impacts that are being felt on both the living and non-living components of the environment. First, the higher temperatures are affecting organisms that have life cycles that vary by stage with seasons. So, for example, many species of birds have a specific mating season that occurs during the year, which is dictated by temperature conditions. And scientists have documented many species of birds breeding earlier in the year because winter temperatures aren't lasting as long and the onset of spring is happening sooner. These figures here show on the right-hand side a backslide in the timing of the spring onset, showing that spring is starting earlier in the year. And then on the left, a corollary backslide in the date at which surface-feeding seabirds in the Pacific Ocean are hatching their eggs. But mating seasons aren't the only aspect of life cycles that are affected. Birds and butterflies that have migratory patterns are also traveling earlier in the year, and amphibians are spawning earlier in the year in response to higher temperatures. Another observable effect of climate change is the advancement of mountain tree lines to higher altitudes. If you've ever spent time in a high altitude region like the Rocky Mountains, for example, you may have noticed that the forest grows densely, but then it stops rather abruptly at a certain altitude, as you can see in this image. And the point where it stops is called the tree line. And the reason why tree growth stops after a certain point is because above this point, temperatures are too cold and there's too much snow and ice pack for too long during the year to support the tree growth. But in various parts of the world, the tree line is advancing upward on the face of mountains because with higher temperatures, there is a larger habitable zone for trees at higher altitudes. These images show an example comparing the tree line in a region of the Appalachian Mountains in the year 2018 on the left and 1978 on the right. So the older image is on the right. And at first, it's difficult to see the difference. The change happens very gradually because trees grow slowly. But if you focus on that trail, that line of trail that's cutting up the left side of each image, and then it takes a right-hand diagonal turn, and you compare the tree lines in the 1978 right-hand image to how close the trees are to the trail in the 2018 left-hand image, it's clear that the tree line is encroaching on that trail and getting higher up the mountain. So tree lines are getting higher, and just in general, certain plant species are capable of inhabiting new regions that were previously too cold to support them. This is seen especially with Arctic shrubs that are moving into new territory that used to be too cold for them. It's also happening with certain animals as well. One animal whose habitat range is shifting in a way that presents a major public health concern for humans is the mosquito. So mosquitoes are an insect that is highly constrained by climate. They can't survive when it's too cold. So with warmer temperatures, the habitat range of the mosquito is expected to increase, and they'll extend their territory into new areas and bring with them diseases that they carry. These images here show on the left-hand side the habitat range of the Aedes aegypti mosquito in the year 2000. And on the right-hand side, there are projections for how the habitat range will expand by the year 2100. And Aedes aegypti is the mosquito species that carries Zika virus, dengue fever, chikungunya, and yellow fever. So big public health implications. Another way that the effects of climate change have manifested is in the melting of Arctic permafrost. Permafrost is ground that remains frozen solid for multiple years at a time, and extensive regions of permafrost are now melting. This is evidenced in this photo here of a drunken forest in Siberia, where the trees are toppling over or growing at weird angles because the soil that they are rooted in is melting and sinking and changing shape. So frozen ground in the polar regions is melting, and so is ice. The area of Arctic sea ice has been declining, and this is reflected in lower amounts of ice at all times during the year. In this graph, you can see the gray line This represents the median area of ice between the years 1981 and 2010. And then the individual colored lines represent each year between 2016 and 2020. And you can see that the recent years are much lower than the average between 1981 and 2010. Ice is also melting on the other side of the world in Antarctica. Major ice shelves of Antarctic sea ice have been disintegrating and collapsing. In 2002, a section called the Larsen B ice shelf, which was approximately the same size as the state of Rhode Island, collapsed into the sea over the course of a few months. And then in 2017, a huge chunk of its neighboring Larsen C ice shelf also collapsed. Another type of ice is also under threat. Glaciers, which are essentially massive frozen waterways, are retreating in the area that they cover. So on the left, there's a pair of photos of the Peterson Glacier in Alaska's Kenai Mountains. The leftmost photo of the pair is taken in 1917, and the right photo was taken in 2005. And the two photos are almost unrecognizable as being the same spot, but you can see that the mountains in the background of each photo do mark them as the same place. The difference is that a huge volume of the glacier has melted and receded. Now on the right, there's another pair of photos of the Muir Glacier, also in Alaska. The one on the top was taken in August 1941, and the one on the bottom was taken in August 2004. So again, almost unrecognizable as the same geographic area, but the surrounding mountains show us this is the same space, but the ice has turned into a liquid on the bottom photo, and you can see just what's left of the remaining glacier far in the distance. And as all of this ice is melting, a larger proportion of the water on Earth is being turned into the form of liquid rather than a solid, which is causing sea levels to rise. Specifically, sea levels have risen 8 inches or 20 centimeters since the year 1880 and are projected to rise much more. This, of course, puts coastal regions and island nations at risk. One interesting case study of this is the island of Newmore, which was an island in the Indian Ocean between Bangladesh and India, and the territory was disputed. Both countries laid claim to it, but the dispute was settled by climate change in 2010 when the ocean swallowed it up and the island no longer exists. It's underwater. You can see the progression of this in these 3 satellite images taken in the year 2000 on the far left, the year 2010 in the middle, and then the year 2011 on the right when it is gone. Another effect of rising temperatures is the bleaching of coral reefs due to the warming of the oceans. So much of the excess heat that the Earth is trapping with the enhanced greenhouse effect is getting absorbed by the oceans, which raises their temperatures. But when this happens, the coral in coral reef ecosystems becomes stressed. Normally, coral have a symbiotic relationship with algae that live on the surface of the coral. The algae serve as a food source, and they also create a protective coating on the exterior of the coral. But when the coral are stressed by high ocean temperatures, the algae no longer grow on them, which leads to an appearance known as bleaching, and that leaves them vulnerable to starvation and disease. And rates of bleaching are on the rise. In 2016, there was a mass bleaching event that killed 29% of the shallow water corals in the Great Barrier Reef. And according to the National Oceanic and Atmospheric Administration, between 2014 and 2017, 75% of coral reefs on the planet underwent bleaching. And finally, drought and desertification are increasing in many regions around the globe. Drought is a period of time with lower than average levels of precipitation, and desertification is the conversion of other types of ecosystems like forests and grasslands into desert, which is a phenomenon that is linked to drought. As one example, the Sahara Desert in Africa grew in area by 8% between the years 1950 and 2015. And what we see here is satellite imagery of Lake Chad, which is a large lake in Central Africa located on the borders of the countries of Chad, Niger, Nigeria, and Cameroon. And as you can see, the lake is drying up and the desert is encroaching. The loss of the lake is likely due to a combination of both direct human use by overdrawing the lake for agriculture and also shifting rainfall patterns due to climate change and the lake failing to be replenished. So these are some of the effects that the changing climate is having, that we're already seeing. The last topic in this lecture that we need to cover is what we can expect in the future. So projections for what we expect for the future of the Earth's changing climate are complicated to put together. They include a wide range of variables, everything from the amount of carbon dioxide that we emit to the amount of deforestation or reforestation that will take place, to the amount of heat that the ocean can absorb. And one of these variables, the amount of carbon dioxide that humans emit, is constantly changing. For some countries, emissions are going down. These are mostly the rich, already industrialized countries that have the available capital to invest in setting emission goals and enforcing regulations and upgrading to clean energy technologies. So as you can see in this graph, some of the countries with declining emissions are the United States, Germany, and the UK, and Mexico is more recently on a slight decline as well. For other countries, emissions are going up. And this group largely includes the less wealthy countries that are in the process of industrializing. So China's emissions, as you can see, have skyrocketed over the past 40 years, and India is also on a strong upward trend. Other countries have much lower total levels of emissions, but nevertheless are showing upward trends that are just as steep as India or China. For example, in this graph, I've included some of the nations with the largest economies and populations within the African continent, which are rapidly industrializing as well. And if you put these on the same graph with China, the US, and India, they'll look like little blips at the bottom because their total level of emissions is dwarfed by these other nations. But when we put them on their own graph, we can see that they are increasing rapidly. So all of this to say that carbon emissions are constantly in flux, and for this reason, making predictions about where climate change is going to take us can be challenging, but we do have some models of different scenarios that tell us what can be expected under different circumstances. These figures here show the consequences for global temperatures in several different carbon dioxide emission scenarios. The graph on the left, the black line, is what has been measured historically. So that's what we know to have been observed about CO2 emissions until this point. And then the various colored lines that branch off from that black line represent a few different scenarios of where we could go from here. The red line represents a version of the future where carbon dioxide emissions continue to grow exponentially through the year 2100. The orange line is a middle high emission scenario, and the blue line is where the world cuts emissions, and the green line is where the world dramatically cuts emissions and rapidly lowers carbon dioxide in the atmosphere. On the right, we see a graph depicting the temperature-related outcomes of those different scenarios, measured in degrees Fahrenheit increase over the global average between 1901 and 1960. The highest emission scenario is predicted to produce, as we might expect, a large increase in temperature ranging between 5 and 10.2 degrees Fahrenheit. The mid-high scenario is expected to increase temperatures between 3 and 6.8 degrees. The low scenario between 2.4 and 5.9 degrees. And the lowest, if we dramatically cut emissions, between 1.1 and 4.3 degrees. And given that ice caps are already melting under the 1 degree increase that has taken place so far, we can expect that further melting will take place. The Earth's albedo will decrease. This will generate a feedback loop of warming because less solar energy will be reflected and more will be absorbed by the Earth's surfaces. Needless to say, the outlook under a high emission scenario does not look good. And so the question that many ask at this point is what can be done? But that question is beyond the scope of this chapter. This chapter looks at what the science says about climate. But in our forthcoming chapter on energy, we'll tackle the question of what can be done by learning about renewable energy sources and how they compare to fossil fuels.